10.7 Circles in the coordinate plane. Essential question: can I write and graph equations of circles? Can I do a coordinate proof involving circles? Let's take a look at a circle whose center is at the origin. Notice that all the points have the same distance, which means I can go ahead and use the Pythagorean theorem. A squared plus b squared is equal to c squared. Our leg is x squared. The other leg will be y and then square it, and the hypotenuse will be r squared. This is what we call an equation of a circle, centered at the origin with radius r. What happens if the center is not at the origin? So let's make it hk. And again, all the points around it have the same distance r. We'll call one of the points on the circle xy. Let's go ahead and figure out this change in x, and the change in x will mean that I'm going to subtract this x with this x, and that'll give this length of this leg. Then I will subtract the two y's, this y and this y, and that'll give the y change. I then go ahead and use the Pythagorean theorem. A squared plus b squared is equal to c squared. This is my leg, so I'm going to write x minus h quantity squared. This is my other leg. I'm going to write y minus k quantity squared, and I'm going to write the hypotenuse r squared. Now, make sure you understand that hk represents the center. hk is the center. And notice that the h is after the subtract sign, because that's how we figured out the distance, and k is after the subtract sign as well. And the radius is equal to r. Let's go ahead and do a problem. We want to write the standard equation of each circle. Now we notice that in A, the center is at the origin. When the center is at the origin, the formula looks like this. The only thing we have to figure out is the radius. And it looks like the radius is 3. And notice over here it's 3, and notice over here it's 3, and so on. In fact, any point, a point to any part of the circle is going to be 3. So all I'm going to do is substitute, and for r I'm going to write 3 and squared. And this is what we call the standard equation. This is the answer. It describes this circle. Now let's go ahead and do a circle with center 0, 9. So 0, negative 9 is right about here. And we want a radius of 4.2. So our radius is going to be 4.2 this way, 4.2 this way, actually anyway 4.2, and we're going to have a circle. And we'd like to find the equation of that circle. When the center is not at the origin, we use this form, x minus h quantity squared plus y minus k quantity squared is equal to r squared. I'm going to rewrite the problem without the h and without the k. And I'm going to put without the r too. And then I'm going to put my radius of 4.2 squared, and my h will be 0, and my k will be negative 9. Let's clean up the format, and since this is subtracting 0, I'm just going to say x squared, and two negatives in a row mean y plus 9 squared is equal to 4.2 squared, and we'll just leave it that way. And that's what we call the equation of the circle. Okay, your turn. Stop the screencast and see what you can do. And here's the answer. Here's the standard form when h and hk is not 0, 0. This one happened to be 0, 0. So really all I had to do is put the 2.5 in for the r. And here I went ahead and substituted negative 2 in for h, and I substituted 5 in for k, cleaned things up a little bit, and that was my equation. All right, we have some points, point on the circle and a center, and we would like to write the standard equation. So we know that the standard equation is x minus h, quantity squared, plus y minus k, quantity squared, is equal to r squared. And right now, we do know our h and our k. We just don't know our r at this point. So I'm going to substitute, this is the center, so I'm going to substitute -1 in here and 3 in here. And the radius I'm going to have to figure out by finding this distance right here. So I'm going to find the distance between those 2 points. That's going to be 5 take away -1 squared plus 6 take away 3 squared. And then this is going to be 36 plus 3 squared will be 9. So this will be square root of 45. So we'll put square root of 45 as my radius. Clean things up a little bit. X plus 1 squared plus y minus 3 squared. And if we want to make that a little cleaner, we can say 45, or we can just leave it this way. That's okay. That way we know what our radius is. Let's review some algebra from last year. Let's review perfect squares, not perfect squares. These are perfect squares because x plus 4 times itself. And then it ends up looking like this. It's a square. Now this is not a perfect square because it's not the same number. These are perfect squares. They're exactly the same number. And then they're square. So these are perfect squares. And again, this is a perfect square and this is a perfect square. Okay, let's take a look at the characteristics of a perfect square. I'm going to use FOIL, and I'm going to multiply out perfect squares. The first term, the outer, the inner, and then the last term. So I've done this in each case, and then I have simplified. I want you to notice that the last term, which is 4, and notice the middle term coefficient. Last term, middle coefficient. Last term, middle coefficient. Last term, middle coefficient. Now I put a in here instead of a number. And I went ahead and did first, outer, inner, and last. And then I got this. And I want you to notice a very interesting relationship, that whatever this is, a squared, this is 2a. And then with negative numbers, I am going to get a negative number. And again, if you think about it, the way to get this last term right here is to take half of this number, so that'll be -a, and then after you get -a, go ahead and square it, and we get this. And that's what happens in each one of these things. In order to get the underlined red, you are going to take half of this number, which is 2, square it, and you end up getting this. Take half of this number, -3, square it, and you will get the last number. Take half of this number, 1, square it, and you will get your last term. Take half of this number, -7, square it, and you will get this. Take half of this number, a, square it, and you'll get your last term. Okay, let's see if you can follow through on what I've just done. I'm going to take half of this number. I'm going to take half of 6, and after I get half of 6, which is 3, I'm going to square it, and that's the number that's going to go here. Stop the screencast and see if you can find the last term here to complete the square. Okay, here are the answers. I am going to take half of this number, which is 5, square it, and that's how I complete the square. And then this will be x plus 5 times x plus 5, and then it'll be a perfect square, x plus 5 squared. I'm going to take half of this number, which is -4, square it, and that'll be 16. Now I can factor this, and it'll be x, and the square root of that is 4. Now since I have a negative here, both of these are going to be negative, and then I could write it as x minus 4 squared. Take half of this number, 6, square it, 36. And now when I factor, I'm going to have x, and take the square root of 36, that's 6 and 6. Make them both positive to create the 12, and you're going to get x plus 6 squared. So this is what we call completing the square. All right, let's take a look at this, and this is going to require repeating the square. We want to find the center and the radius of the circle. We have to get it to make it look like this. And right now, it doesn't look like that. The x squared here, there's an x, negative 8x, there's a y squared here, there's a 4y. And it doesn't look a thing like this. So what I'm going to do is I'm going to arrange it so that I have all the x's together. I'm going to leave a space. I'm going to put all the y's together. I'm going to leave a space. And then I'm going to take this and put it to the other side, which is 16. So all I have done is rearrange things. That's all I've done. Okay, now I'm going to complete the square. I'm going to take half of this number, which is negative 4, square it, and that'll be plus 16. But if I add a 16 to this side, I must add a 16 to this side. Now I'm going to take half of this number, which is 2, square it, and that's going to be plus 4. But if I add a 4 here, I must add a 4 here. Now what happens now? Well, this now becomes x, and this is going to be a 4 and a 4 because that's 16. Take the square root. This is minus, minus. And if I factor this, this will be y. Take the square root, 2. Since this is positives, I'll make both of these positive, equals, and this is 32 plus 4, which is 36. Now I'm going to write that in the square form, and then I'm going to write this in the square form, and that's 36. I'm going to do one more step to help you. I'm going to rewrite this as y take away a negative 2 squared equals 36. Now it looks very much like this. And I can see the number after the subtraction sign will be my h, the number after the subtraction sign will be my k, and my radius, remember this thing has to be squared, and that number is 6. So the radius is 6. So we're going to take one more step and graph it. And so this is going to be 4, negative 2. And then we're going to go out 6, 6, 6, and 6. And we'll have our circle. Okay, now it's your turn. Go ahead and stop the screencast and see what you can do. And here are the answers. All right, let's go ahead and do a proof where we prove or disprove that this point lies on the circle. So I'm going to draw a picture, and this circle center is at the origin, and there is a point on the circle, 2, 0, which tells me that the radius is 2. So I'm going to go ahead and draw my dotted line for dotted circle for my circle. The question is this point sitting on the circle somewhere? So is this point sitting on the circle? Well, the way we figure that out is by first find the equation of the circle. So I'm going to write, since this is centered at the circle, x squared plus y squared, and I know my radius is 2, so this is going to be 2 squared. Now the question is this point part of this set of points? So I'm going to substitute in for x and y and see if I get this answer. So I'm going to write root 2 in for x, root 2 in for y, and I get 2, and I get a 2, and I get a 4, and this definitely does equal. So we say yes, root 2 is part of the circle. Okay, we want to prove or disprove whether this point lies on the circle, and you can see I drew a picture and I wrote my equation, and then I asked, is this point part of the circle, so I went ahead and substituted. Notice how I left this blank. I'm not quite sure if it's going to work or not. I wrote 1 plus 5, and I can see that does not equal 1. So this disproves it and says, no, this is not part of the circle. Now, where's the graphs of circles used? They're used in studying earthquakes. If we can get 3 readings, and graph these 3 locations, then where they all intersect is what we call the epicenter. So why are 3 seismographs needed to locate an Earth's epicenter? Well, if you only had 2 circles, the 2 circles would intersect and it'd be 2 points, so we wouldn't know which one. So we need the third circle, like we did up here, to see where they all 3 intersect. And this is the end of the screencast.